Welcome you all in online lecture series organized by Brahmadev Dadamane Polytechnic Solapur. Myself Dr. Prof.Bhalerao. Today we are going to discuss about the course Basic Science Physics. In this course the unit second is Electricity, Magnetism and Semiconductor. In this unit, the first electricity included the articles electric flux density, expression of electric field intensity, electric potential difference. First, electric flux. The electric flux is denoted by a Greek letter psi, which is pronounced as psi. Electric flux definition: the total number of electric lines of force starting from a charge is called as electric flux. Also, by definition, 1 coulomb of electric charge gives rise to 1 electric flux. Therefore, psi is equal to Q and Q measured in coulomb. Thus, the electric flux is measure of overall size of electric field. Electric flux density, capital D, it is defined as the number of electric lines of force normally through unit area. Therefore, D is equal to flux density upon area, and D is equal to psi upon A, and the electric flux density SI unit is coulomb per meter square, which is obtained from the formula D is equal to psi upon A. Psi is the electric flux and A is the area. Near the charge D is maximum, also E is maximum. Therefore, we can say electric flux density is directly proportional to the electric field intensity. Now, the expression for electric field intensity due to point charge. In the figure, the force between Q and Q0, F, and the distance between them is small r. Let Q is equal to point charge placed at a point O. Q0 is the positive test charge placed at a point A within the electric field of charge Q, and R is the distance between Q and Q0 charges. Now calculate the force between Q0 and Q. Then the formula for force F is equal to 1 upon 4 pi epsilon 0 into Q0 upon K into R square. This formula is obtained from the Coulomb's law or Coulomb's formula, and this formula equation 1. Then the next is, but E is equal to F upon Q0. E is the electrical intensity, which is equal to F means force, electric force upon Q0 charge. In this equation, the force value, the value of force in equation 1, putting in this equation, then we will get the equation second. 1 upon 4 pi epsilon 0 into Q0 upon Kr square upon Q0. In equation 2, Q0 get cancelled, and we can write equation 3, E is equal to 1 upon 4 pi epsilon 0 into Q upon Kr square. Here again in equation 3, 1 upon 4 pi epsilon 0, the value of this quantity calculated, which is equal to 9 into 10 to the power 9, and this quantity putting in equation 4, E is equal to 9 into 10 to the power 9 into Q upon Kr square. This is equation 4, and equation 4 represent the expression for intensity, that is electrical intensity. Now the electric potential, which is denoted by V. The electric potential at a point in electric field is defined as the amount of work done to bring a unit positive charge from infinity to that point against the direction of electric intensity. It is given by electric potential which is equal to work done upon charge. In equation form we can write as V is equal to W upon Q. W is the work done to bring a test charge Q from infinity to given point, and the SI unit of electric potential V is volt. In shortly we can say V. V is the short form of volt or symbol of volt, or joule per coulomb. And the definition of 1 volt is, we know that V is equal to W upon Q. Then 1 volt is equal to 1 joule upon 1 coulomb. Then the definition is the electric potential at a point is said to be 1 volt if 1 joule of work done in displacing a charge of 1 coulomb from infinity to that point against the direction of electric intensity. Now the example on electric potential. Number 1, find the electric potential if the work done to move a charge of 100 microcoulomb from one point to another is 5 joule. Then the solution, first of all we will discuss about the quantities given. The given quantities Q is equal to 100 microcoulomb, which is converted into coulomb 100 into 10 to the power minus 6 coulomb, and work done is equal to 5 joule, and V is the electric potential we will find out by the formula V is equal to W upon Q. In this equation, in this formula, the above quantities value or values of the quantities given in this formula, or putting the values of above quantities, then we will get 5 upon 100 into 10 to the power minus 6, and again this calculate, then we will get 5 into 10 to the power 4 volt, and the voltage we can say V is equal to 5 into 10 to the power 4. Now the electric potential difference between 2 points in an electric field is defined as the work done in moving unit positive charge from one point to another. It is given by VA minus VB is equal to WB minus WA upon Q. The SI unit of potential difference is equal to volt. Now the example on electric potential difference. First example, find the potential difference between terminals of battery if 240 joule work is required to transfer 20 coulomb of charge from the one terminal to another terminal. In this example, the given quantities W, that is work done, is equal to 240 joule, charge 20 coulomb, and the potential difference we will find out. The potential difference formula is equal to W upon Q. In this formula, the above values putting, then we will get 240 upon 20. Calculate this quantity, then we will get potential difference is equal to 12 volt. Now the second example, find the work done when a charge of 50 microcoulomb is moved from a point at a potential minus 10 volt to a point at a potential of plus 30 volt in an electric field. Then the solution, first of all, given Q is equal to 50 microcoulomb, which is converted into coulomb, which is equal to 50 into 10 to the power minus 6 coulomb. VA, potential at A point, which is equal to minus 10 volt, and potential at B point, VB, is equal to 30 volt. Then the formula VB minus VA is equal to WB minus WA upon Q. In this formula, WB and WA is the work done. We can combinedly say that WAB, and therefore the formula we can write WAB is equal to Q into VB minus VA, and in this formula the above values of the quantity given the above quantities or values in this formula putting, then we will get 50 into 10 to the power minus 6 into 30 minus 10. Then when the calculate this quantity, we will get 50 into 10 to the power minus 6 into 40, and this quantity we can calculate it again, then we will get 2000 into 10 to the power minus 6. This figure we can write as 2 into 10 to the power minus 3 joule, because we calculated here the work done, that is work done WAB is equal to 2 into 10 to the power minus 3. Okay, in this way today we have studied about the electric flux, then electric flux density, after that electric intensity, that is the expression for electric intensity, and electric potential and their example, and electric potential difference and their examples. Okay, thank you.